see the properties for inverse cos. So when you compose inverse cos with cos x, the answer is just x. Without any calculation, we can just cut and paste the answer. However, we must be careful. Our x must be within the domain of cos. Alright, so take care of the function inside, which is cos. Therefore, x must be between 0 and pi. You must make sure it is within quadrant 1 or quadrant 2 only. The second one, cos compose inverse cos x. This is just equal to x. Alright, you can just cut and paste the answer. However, please make sure that x is within the domain of inverse cos, okay, the inside function here. So domain for inverse cos is again from -1 until 1. Now let's see the example here. Find the exact value using the properties. Inverse cos cos pi over 12. Alright, so let's see here, pi over 12, we must make sure that it is within the domain of cos, which is between 0 and pi. So pi over 12 is in the first quadrant. Therefore, we can just take the answer here and just write our answer as pi over 12. Now let's see the second one, inverse cos, compose cos negative pi over 6. So again, we need to make sure that this value here is inside the interval 0 until pi. However, negative pi over 6 is outside of the interval. Okay, negative pi over 6 is actually here. It is in quadrant 4, which is you're not allowed to be here. So please don't straight away assume that this is undefined, okay? Because originally the domain for cos is from -infinity until infinity. You can accept all. However, for the purpose of inverse cos, we have cut it between 0 and pi. So we need to consider it. We should use reference angle. Okay, I have explained this during the inverse sine function. However, we can use another shortcut. We can use even odd property. So let's use the properties here. You can use even properties for cos. Cos negative theta is just cos theta. So let's use it here. Cos minus pi over 6 is just cos pi over 6. So now pi over 6 is within the quadrant. This is in quadrant 1. Is within the interval 0 and pi. Therefore, we can just take the answer. This is just pi over 6. This is almost the same with part B. Inverse cos compose cos negative 2 pi over 3. So obviously, this is a negative angle. This is outside of interval 0 and pi. So we need to adjust this. We need to use reference angle. However, we have a shortcut way for this. For negative angle, we can solve this by using even odd property. So again, let's use even odd property, which is cos minus theta is equal to cos theta. Therefore, cos minus 2 pi over 3 is just equal to cos 2 pi over 3. So now let's use the properties. Inverse cos compose cos 2 pi over 3. This is now within the interval. This is 120 degrees. So 120 degree is here. So this is inside the second. So we can accept this answer here, 2 pi over 3. This is within our domain. Therefore, our answer here is just 2 pi over 3. Now let's see question D. Cos compose inverse cos negative half. So be careful. Now we need to take care of the domain of inverse cos, which is it must be domain of the interval -1 until 1. So minus half is within -1 and 1. Therefore, we can just take this answer here. Your answer is just negative half. Finally, for this example on inverse cos, let's see here, cos compose inverse cos pi. Again, we need to take care of the domain of inverse cos. So inverse cos, the domain must be between -1 and 1. So now your pi is actually the value of 3.142 ... So this is 3 plus. Obviously, this is over the interval here. Therefore, we cannot solve this. This is undefined.